My name is Anthony Scopatz. I'm a professor of nuclear engineering at the University of South Carolina. And I'm going to talk to you today a bit about diversity theory and what that is. And this is sort of a non-standard diversity talk in the sense that takes a more quantitative and empirical approach to diversity than you might normally see in a diversity talk. So if you're interested in stalking me on the internet, here's some more information about me just to tell you. So I'm a Python Software Foundation Fellow, the founding treasurer and former board member of NumFocus. Stepped down from that role a few years ago. My research group is called ERGS. But if you've heard of me on the internet, it's probably through this like wacky Python shell bash hybrid project called Conch, or through this book called Effective Computation in Physics that I wrote with Katie Huff. Okay, so that's who I am. You can go and find me elsewhere. All right, so when I was preparing for this talk and sort of mulling over it for the whole summer, I started with a few motivating questions about diversity and diversity issues. And so I just thought I'd put those up initially so that we could sort of start from the same page. So the first one is that if diversity is such an important topic, why don't we have a rigorous mathematical approach to it, right? For everything else that we do, especially for people in this room, we have a rigorous mathematical formulation. So why don't we have one for diversity if we think diversity is such an important topic? What is the science of diversity? Is there a science that exists that we can go and borrow from? You know, maybe other people have thought about this. And given that, can we engineer equitable systems? Right? I think this is the purpose of studying diversity in this way, is to design equitable systems. And if so, how do we do it? And if not, why not? And what are the problems? So these are the questions that I started with. So it turns out there is a diversity theory, right? If you go to ecology, they've actually had a definition of diversity since the 1960s. So this stuff isn't even particularly new. And if you look at their definition in sort of the canonical ecology paper on this stuff, they just say, information content may be used as a measure of the diversity of a many-species biological system. So bam, done, information equals diversity, we can all go home, right? Not exactly, there's a little more subtlety. They've been thinking about this since the 60s, but the basic premise is that we can use information as a proxy for diversity. And in particular, they kind of break this down into two components. So they have a gamma component of diversity that they set equal to an alpha times a beta. And so the alpha component is if you take one particular region and you look at the diversity just within that subregion, that's your alpha. And then that is separate from the diversity between different regions, right? So if you think about this sort of geographically, this is how they break it down. Not so bad. This has a few interesting premises and side effects, though, so that we can maybe just look at what those are. So they have some intuitive basic properties of what they feel like diversity should mean, and from these definitions, we'll go and see some of the mathematical ramifications. So just to list them off, the first one is that alpha and beta components should be independent, right? So that the diversity within the group, it should be separate from the diversity between groups. The same value, the same number, if you get the same one number for diversity, that should denote the exact same amount of diversity if you were to go and measure the other number. So this means that basically you want alpha and beta to be measured on the same scale. They're equal valued systems. And that seems like a reasonable thing to assume. Alpha is an average diversity. It's not talking about individuals. It's talking about populations. Another reasonable assumption, perhaps. And then gamma must be completely determined by alpha and beta. There's no hidden variables in this system. So this is the complete description of diversity. And then finally, alpha must be less than or equal to gamma. Okay? Pretty reasonable assumptions. It actually took them up until this decade, more or less, to kind of agree that this was the set of reasonable assumptions. So there's been a lot of debate over the past 50 years, 60 years, but this is what's happened. So interestingly, there's some repercussions for this. So one is that you can't define gamma as the sum of alpha and beta. It has to be the product if you take these assumptions. If you try to use this, this formulation, various of these properties fall apart. There's a lot of debate about why that is, or there was a lot of discussion about why that is. Additionally, if you want to use information or entropy as your diversity, it actually can't just be used directly. And so entropy becomes this thing that they term a diversity index that then you adjust to become the diversity. So the alpha or gamma equals alpha times beta equation, if you just use entropy directly, it doesn't actually conform to those basic principles. So you have to do something else, which means that your diversity D is actually a function of entropy H. We'll talk about what that is. Okay. So there's a few different notions of what your diversity index that are common in ecology that you can look at. And they're all relatively simple. So this paper, or this is just taken from this one juiced paper here. And at the base level, there's this thing called species richness, which is just the sum of your populations to the 0th power, which sum together, which of course just equals S, so the number of groups. So this is just a measure of the total number of groups or species that you have in your system. And if that is your diversity index, then your diversity, D of H, is just equal to H, or equal to S in this case. Alternatively, right, since we're talking about information, you could just use the Shannon entropy, which is what people did originally. So if you use this Shannon entropy as your diversity index, the diversity is then just the exponent of your Shannon entropy. So it's not hard, right? This is like one expression in Python. It's not a lot of work. And then there's some others. Probably the most interesting one is this Renyi entropy, which looks a lot like the Shannon entropy, but with this Q term that we'll talk more about later. And then, sort of importantly, if you take this as your diversity index, or if you take the Renyi entropy as your diversity index, the diversity as a function of that is just the same exponent. So, not so bad. Okay, so economists talk about diversity in using the terminology numbers equivalent. If you haven't heard this term before, which I hadn't before diving into this stuff, but numbers equivalent just means sort of the total number of effective elements, or if you come from a physics background, it's equivalent to the number of states that you have. And it's importantly, if you have a diversity of order Q, this diversity of order Q is what follows our ecologist representation of gamma equals alpha times beta. So QD H gamma is what's equal to QD H alpha times QD H beta. And you can pick any of those H's that you want, and they all will follow this equation. Okay. And the sort of shocking and particularly interesting fallout of all of this is that for any of those entropy measures that we had, or any of those diversity, or those entropy indexes H that we had on a previous couple slides ago, this very simple expression falls out. So diversity of order Q is always, you can always say it's equal to the sum of your populations to the qth power, and then that sum itself to 1 over 1 minus q. Okay? And if you go through for all those diversity indices, you can show this. This was actually discovered through the Renyi entropy, which is why the Renyi one is probably the most interesting. It also has some other population implications. So this is pretty cool. And so that really means we just need to pick a Q, right? So which Q do we use? So if your Q equals 0, we're just back at the species richness, right? We're just back at the total sum, the number of partitions or the number of groups, S. If we have a Q less than 1, we're disproportionately affecting, or we're disproportionately counting rare species. So if you're interested in like looking at more minority or small population groups, you would choose a Q less than 1. If you choose a Q equal 1, the limit of that just falls out to the exponent of the Shannon entropy like we had before. So that's pretty cool. And then if you take Q greater than 1, which you probably wouldn't do in this context, you're disproportionately sensitive to common species. So these are sort of the bounds of this equation with respect to Q. Oops, is that the next one? Yeah, okay. So I think, you know, if you'll note, basically we've spent the whole time so far talking about ecology and we haven't actually mentioned humans at all. And so, you know, there's this open kind of philosophical question of whether humans are important. And we're just going to take axiomatically that humans are for the rest of this talk. If you don't believe that, like, please return to the internet. So that was the joke for this talk, so you should get the laughing in now. Yeah, okay. So that being said, how do you, given that we're actually trying to deal with humans and not species of like insects in the tropics or something, you know, how do you define fairness, right? So we need to pick some Q, so which Q do we pick? Which order do we want to look at? And if you pick Q equals 1, you're actually fair to individuals, individual members of your broader population. But if you want to be fair to each group with respect to each other group, you would pick a Q of 1 over S, or 1 over the number of partitions that you have. And so that's less than 1, and so it's kind of favoring each group on its own. And if you want to measure, if you want to be fair to both groups and individuals equally, you'd choose Q equals 2 over S. Not so bad. You have to pick a Q, so here's some ideas. I'm not saying which one you should pick, but at least this gives us an axis on which to analyze things. But I'll note that whoever gets to choose the partitioning actually has a lot of power, right? If you get to sit down and determine what groups are available or what buckets people are allowed to fit in, then you have a lot of power. And that actually shows itself in the math here, right? It falls out, which I think is pretty cool. Additionally, you might think you could get around this by having people just self-report whatever group they're in, but you know, you might not want to do this because then you might not want to take this to its logical extreme, because then you just end up with so many buckets that your S is huge. And so you might say, well, maybe we should have some minimum population threshold before we count a bucket. But you're back at the same problem, because who gets to decide that threshold? And so that also falls out, right? Like there was this case in the UK about 10 years ago, right, where Jedi was declared like a religion because they met the maximum threshold of people. And you know, not to say anything against the Jedis, but like there's clearly some threshold issue going on here. So with their census, so that again falls out, which is kind of neat. Okay. So I think the problem with diversity really is that it's not a sufficient measure for what we're trying to achieve. And we'll prove this sort of through a counterexample, right? So just saying, if diversity were sufficient, right, if diversity were enough to sort of address all the problems that we cared about, then diverse collections would always be preferable to homogeneous collections. And I don't think you need to go further than the definition of empire to realize that that's not necessarily a true statement. Right? So if you look at the formal definition of empire, it says that an empire is an aggregate of nations ruled basically by a single government. And so empires, by definition, are diverse places. They have to be diverse. But you know, there's many examples in the historical record where empires are not necessarily more equitable or nicer places to live for most of their population. And so I think this sort of helps show that diversity, even though what we call diversity isn't really what we're driving at. And so maybe what you want to do is sort of replace all the instances of diversity with equality. And that is something that we should be looking at in this whole first part of the talk, where we're thinking about bugs in the tropics is not really the right way to go. So let's kind of shift gears a bit and try to think about equality. So I wanted to talk instead, before we really dive into the math here, sort of an anecdote from other parts of society. So I actually think that PyData and the scientific community in STEM as an element of the broader society is doing relatively well. That's not to say that there aren't problems and that there aren't issues, but if you look at other parts of society, so let's take the field of dance, for instance, and we'll go through this, they have much, much more significant issues along diversity and equality than we do. So if you look at dance, many, many children go into dance, and the overwhelming number of them are female, especially in this childhood range. And this is anecdotal because hard data doesn't exist, so I apologize about that. Once dancers hit college age, most people drop out of dance by that point, but those who remain, it's roughly 70% female and 30% male. So if you go to your average dance department at a university, this is what the sex split will be. And so that's probably representative of the people actually interested in dance as a profession. And then if you go to the young professional stage, sort of by virtue of the way the system is constructed, there's about as many male roles as female roles. They have sex parity in dance. This is a real phenomenon. If you go to your average young professional junior developer dance company, right, they're 50-50. But then you get up to the senior level, right, senior dev, choreographer level, and especially among the big name choreographers are overwhelmingly male, even though they started opposite, right? So, we might talk about a pipeline problem, like dance has a pipeline problem. And they're really only beginning to even acknowledge that this is a problem. So the whole culture is very different, right? They don't talk about it. And if you talk to them about it, they tend to say there's nothing that can be done. So depressing, but that's what it is. And so it's interesting because even though there's sort of gender parity or sex parity at various levels, I don't think as a whole you could call the field of dance an equal system. So that's an important point. Okay. So when thinking about equality, we've got a couple more motivating questions that we could ask. So the first one is, can two individuals be equal? And I think in the United States, if you look at this from a legal perspective, the answer is yes. We're most citizens are peers to other citizens. We kind of don't care. We legally wash over any equality issues for the most part, especially in criminal cases. But in a measurement sense, if you're actually trying to measure things, right, people are not necessarily equal. There's tens of thousands, hundreds of thousands, maybe millions of axes on which you might measure someone. And so we're not necessarily equal per se. We're all sort of special snowflakes. And so that, you can kind of, and then the law just sort of says, well, we don't care about that, and averages over everything. Okay, so this is a high-dimensional problem. But that's not really what we're talking about, right? We're not talking about individuals. We're talking about populations. So can two groups of people be equal, I think is the more important question if you're trying to engineer a system. And I think the answer is yes, but like we talked about with diversity, you're going to need an underlying metric to measure to see if you can be equal, see if two populations can be equal. But luckily we have some tools, right? We already sort of saw some of them. We saw some with diversity before. And so ecologists have again thought about this quite a bit. not as much as the diversity issue, but there's a related quantity that they alternately call it equality or evenness. And you can define equality as the measure of a qth order diversity divided by the diversity of a lower order R. And so if you do that, for any Q and R, you get an equality measure. And that's something that you can just go out, again, it's like one Python expression. It's not particularly hard. And you could plug in the numbers if you had the data. And so the most common one of these is just equality 0, 1, which is equal to, again, just the entropy, the exponent of the entropy divided by the number of groups or partitions that you have. And that's equality. Sort of makes sense, right? You've got a bunch of groups of people. How evenly are you spreading out the resources that you might have? Alternatively, you can define the inequality index as just the inverse of equality. So that's useful if you want to think about inequality in this sense. Again, so this is an ecologist definition. Economists have separately derived their own inequality measures, right, as you might expect economists to do. So there's this Thiel entropy inequality measure, and they derived this term, and it's only a couple jumps to realize that this is simply the natural log of the inequality that the ecologists define. So all of these equality measures are actually, even though they come from very disparate parts of science, they sort of focus down on a couple of information-related measures that are not difficult and are sort of the bread and butter of what you might consider data science. You can generalize the inequality measure, the Thiel inequality, if you want. And so if you can get an inequality of order q, so qg just as the natural log of inequality 0q divided by your order. So, okay. Not super hard. Okay. So we have a measure, right? We have something that we can go out and plug numbers into. But when can we say that two populations are actually equal, right? So these are constructed systems. Society is a constructed system. And so you've got to have some kind of engineering tolerance on this, right? Floating point precision doesn't seem like the right route to go for your equality measure. So you want some value here. And the question, and this kept me awake at night for many nights, is like, what is that value? What are those tolerances that you allow on your equality that you can just call it a day and maybe you can't do any better than that? And so, what is that threshold? And so there's a couple ways to approach this problem and think about it. And sort of maybe the first one that comes to mind is if you look at voting and polling tolerances, right? They typically publish errors in the range of 3 to 5%. These are big societal measures. Maybe 3 to 5% is appropriate. I sort of feel that that's a little high, actually. And so that's not something that, I would be kind of uncomfortable if 5% inequality was what we were aiming for. But especially if you look at economic measures, like gender pay gaps and things like that, maybe a better place to look is the minimum change the Federal Reserve can make to the interest rates, right? So if you look at this, the minimal value the Federal Reserve can adjust interest rates by is 25 basis points or 0.25%, right? So maybe you could say two populations are equal if their average incomes are within, a quarter of a percent of one another. And you, like on a societal wide scale for hundreds of millions of people, you might not be able to do any better than that. Or you might not have any more fine-grained control. Just a suggestion, I don't know what the right answer is. This seems like a reasonable number. But unfortunately, when I say these numbers, they're actually simply a statement of the mean, right? And that's problematic, right? So suppose you had two populations. with the same mean but different standard deviations. Inequality, I argue, is actually also living in the variance or the standard deviation, right? So you care about these higher order moments of your normal distribution. So just imagine, right, maybe this is income along your x-axis that you're distributed along. Well, if you've got a higher standard deviation, these people are the richer folks, and they have an incentive to keep everyone below them at the status quo. And so when they keep everyone below them, that disproportionately affects the population with the lower standard deviation. And so this is one of the reasons why you can see sort of a driving force, if this was the case, to have, even though your means are the same, to within 25 basis points, you might really want to fiddle with the standard deviation significantly. And so this is, again, a problem. So what are the engineering tolerances for the variance? What should your variance be? So if you have your means equal, how close do your variances need to be equal? And so to tackle this, one strategy is maybe you could look at the entropy of the normal distribution, which happens to be a function of the variance, and look at the critical point of that. And if those two things, if you got your variances to within that, you would be able to say your populations are effectively equal in an engineering design system kind of way. Okay, so if we go through and plug in the numbers, right, so we set h equal to 0, and then we solve for sigma squared. And we do that, we get a variance that needs to be within about 6%, and standard deviation that's within about 25%. And that, so okay, so those are some real numbers you can look at. So does this hold up? So this is what those two population curves look like. Again, if your means are the same and your standard deviations are off by 25%, or your variances are off by about 6%. And I think that these populations do more or less in an engineered system, these look effectively equal. There are some differences you can notice up at the top and sort of along the sides and things, but they'll probably wash out. Maybe you could do better, maybe you could do worse, but at least this is a target value that seems reasonable for defining the quality end goal for some of these metrics that you might look at. And there's probably other suggestions out there. This is just one. So I think the point, one of the main points of this talk is that if you have a strategy for minimizing equality differences, you should be empirical about it, right? That should be a data-driven strategy. And if you don't have the data to show that that strategy works, then you should treat what your suggestion is as an experiment and start measuring things while you're running the experiment and see whether it works or not. And that's the way to engineer these systems, engineer broad, large-scale societal systems to be more equitable. But you actually have to go out and measure things or have data. And so just looking at a couple case studies here. So the CDC recently put out an LGB study of high school students and sort of found significant differences between LGB students who were bullied and who had forced sexual intercourse over their heterosexual counterparts. And this was published in the New York Times last week, but these graphs come from the CDC because the New York Times uses pie charts. So let's dive into this data a bit more, right? So these are horrifying differences in the mean if you look at this on a basis versus 25 basis points, right? They're just, the differences just in the mean just blow this out of the water. And that's really troubling. But what I really want to know is I want the time series, right? Are things getting better? Are things getting worse? Do I change my strategy? Do we do what we've been doing? And that's the data that I want to see. But if you go to the CDC, it turns out that August 2016 was the first time they've ever published such a study. So if you only look at the CDC data, you have no idea whether these are good numbers or bad numbers or horrifying numbers, or you're moving in the right direction, you're not moving in the right direction. And so I argue that this is actually a classic data science problem, right? There's poor and missing data, multiple data sources that we might need to draw from, and we need to synthesize information to be able to pull out these equality metrics that we're actually interested in. And the CDC hasn't really done it for us. And there's some other depressing aspects to this. Like, so in the future, like the New York Times probably won't report on this because it won't be news anymore. And then, the CDC definitely does have the ability to gain longitudinal data for subpopulations. But, for whatever reason, for these equality issues, they have not historically. So, okay. So that's sort of the sad case study. On the brighter note, if you look at gender parity at conferences, in particular at PyCon, and in this particular case, measured by the percent women giving talks at PyCon, which happens to track with the percent women attending PyCon, but these numbers are easier to find, the growth rate has just been absolutely staggering over the past 5 or 6 years here. And this is led by Jessica McKellar, and if you talk to her in person or on the internet, she will repeatedly tell you that the strategy that she used to increase these numbers from 1% to 40% in the course of 5 years was direct engagement with individuals. She goes out, she talks to people, she encourages them to apply, she makes sure that they apply, and they get talks. Okay, so this is a strategy where you can think that that might be a successful thing to do, and then if you actually go and measure the numbers, it turns out it's a successful thing to do. Interestingly enough, this also coincided with PyCon, I believe, around 2011, 2010, or maybe 2012, implementing a code of conduct. But if you talk to Jessica McKellar, the code of conduct is not explicitly what drew these diversity numbers. It's the fact that she talked to people. And maybe that's implicit, but it's not a direct driving force. Okay. So I think there are some cases that are understudied in this community, and there isn't empirical evidence that really says that they work or don't work. And these are areas which we could actually use a lot of help and reflection trying to acquire evidence one way or the other that they do work. So I think just to start out, things that almost certainly work, that almost certainly are effective at creating a more equitable system, but just for which there is no data, are codes of conduct for conferences. I think these things probably help. It makes sense that they help, but we don't, we should be empirical about it, and we don't have we haven't done this study. We don't even have Jessica McKellar level numbers from the previous slide to suggest that codes of conduct at conferences are effective. The other thing that likely works, but I think is even on slightly more shaky ground, are codes of conduct for projects. These might help they probably help diversity. It makes sense, again, that they would. And for reasons we'll talk about on the next slide, but there's just not like the evidence, there's not this body of evidence that suggests that they actually help, or that they're maybe the most effective way to help, or any number of things. And then finally, things that might questionably work, but again, for which there's no data, are activities like public shaming and calling people out who break, or conference organizers, etc. People, even at SciPy this year, there are people who advocate public shaming as a valid diversity strategy to increase equality. But my question is, like, where is the evidence for that? Just like for these other two, where is the evidence that any of these things actually works? Um, okay, so the legal standing for projects is actually a really weird thing. If you haven't looked into the legality of an open source project, unless you're part of some broader organization like NumFocus, or you have a foundation like the Python Software Foundation or the Linux Foundation around you, you don't really have legal standing, so it's sort of a loose collection of individuals. And that doesn't sound particularly satisfying in a lot of ways. And you kind of have to put this juxtaposed to things like businesses and universities that do have, in a legal sense at least, workplace protections and ethics codes, and there are ramifications if you break the law or you violate a code of ethics. And I'm not claiming that these are always the best solution or that they always work. I think there's a lot of evidence to suggest that they probably aren't. They are imperfect, but at least they exist, right? With your average open source project on GitHub or Bitbucket or whatever, you don't even have workplace protections. You don't have the university standing behind you. There's just like someone on the other end of the tubes that could do anything. And it could be a bot even. You have no idea, right? So there's, at least they exist. So, and to follow this up, right? I think codes of conduct as a legal tool are even less strong than a software license, especially for projects. So for projects, right? For conferences, it's kind of clear, like the conference organizer has allowed you on the premise, like subject to these rules that are posted prior to you attending. So there's nothing to do there, but you're kind of in the wrong if you break the code of conduct. But on an open source project that there's just a bunch of other individuals, there haven't been these high profile, and I actually couldn't find any in the case law when I went and looked. I couldn't find any cases where someone was sued successfully or unsuccessfully for a code of conduct violation. That's not to say that they don't work, but they don't get to the legal level, and their legal standing as documents might not be much more than sort of bytes on a hard drive somewhere. They don't really have the same kind of gravitas that a license has. And so, if this is concerning, I think it should be concerning, right? Like, there's got to be something that you can do, and maybe that something is joining NumFocus, but but maybe not. That's probably not a solution for everybody. So there's kind of other issues to work out here that haven't been fully solved yet. Okay, so take a moment and breathe, right? The point of this talk was to show that these problems are not intractable, right? We can approach diversity and equality issues from an empirical basis. And they're not like impossible problems. The math isn't even that hard, really. And the purpose of this talk was really meant as a call for action to obtain diversity data. That is the missing piece now, right? We have these metrics. What we really lack is the information and the data to start proving or disproving that certain strategies work, and to run the experiments that we might need to run to engineer a more equitable system. Okay, so that, I'd just like to conclude on some final sort of data points here. So I do believe strongly that strategies to affect equality should be based on evidence, right? We're PyData, right? We should believe in the data, and we should acquire data, and that, like, we're the experts here. This is the thing that we should be doing. We have these metrics, so we can measure things. You might not agree that these are the best metrics, but at least we have a place to start from. There's a whole corpus of literature that you can go out and look at. And it would be good to have that debate, I think, about what the best equality metrics are. I've just shown you the ones that I think are probably the most successful. And again, raw data might be hard to come by. I think there are organizations and places that we could look at in companies and other institutions that might be able to serve a role helping us acquire the kind of diversity data that we would need to start showing things about, whether whether codes of conduct are an effective strategy, whether we could just do this direct outreach, and those kinds of issues, right? We have mechanisms for acquiring data, so let's go out and acquire it. And then if you don't have data to back up a particular strategy, if you have no idea whether something works or not, you should default to the highest state of empathy. So if you don't have any data supporting your strategy, you should always try to do the thing that gives the other person or other group the benefit of the doubt and tries to, maybe they had a bad day, or maybe they just didn't know, and so I think this is an aspect. This is kind of the rule of thumb that I have that says, well, yeah, this is why you should do codes of conduct, but maybe you shouldn't do public shaming without evidence. Okay, and so really the purpose here is to encourage you all to go out and obtain diversity data, and I'll leave it there. So, thank you very much.
Questions? Does anyone have any questions?
Outstanding talk.
Thank you.
Did you look at all at maybe like the health industry, medical, because it seems as if they're looking at underlying populations and how treatments work.
Yeah. Yeah, so I didn't look at health things other than the CDC in this particular case. I think that's a rich mine to go and take your pickaxe to, but I didn't look at it. I was just trying to figure out, if you had that data, how would you analyze it, right? Because I think that's where people get hung up. Is like, well, I have all this data. Now what do I do with it, right? So,
Right.
But we don't even have the data in a lot of cases. So,
Right.
yeah.
And, I personally benefited from Jessica's outreach.
Yeah.
Probably go back 5 years, and the one-on-one, it had that multiplier effect that we talked about yesterday.
Yeah.
It wasn't just a few, but we wouldn't know that it works if she hadn't collected the data.
That's right. Absolutely. Yeah. And so, yeah, I think what Jessica did was amazing because she collected the data, and now basically every conference should be doing this, right? And we can show that every conference should be doing this because it works. Even though it's a lot of effort, it's worth the effort.
So we keep coming back to that. We've got systems that we can use to evaluate the data once we get it, and that we need to be collecting data. What do you think we should be doing to collect data? What kind of data should we be collecting, and how do you think we should go about doing that?
Yeah, so that's an interesting question. So it really depends what you're looking at, but I think, so let's just take the example of conferences for the first part. I think that all conferences should be running entry and exit surveys, and that data should be anonymized and put online somewhere. It doesn't have to be that hard, but if you had that, and it'd be self-reporting, and then people could, other people who are interested in this problem could go and analyze it whatever way they want and try to, make a case one way or the other. So that's the kind of conference attitude. I think it's harder for when you talk about projects, especially with codes of conduct. And so maybe what you could do, you're going to have to, this is kind of more social science-y, but you'd have to assemble sort of a large body of codes of conduct incidents over a wide variety of projects. And maybe if you had a way to, because no one's tracking this, we know there are if a project had a code of conduct violation, I'm going to pick on SimPy for this moment. So there was a person on the SimPy community who was effectively asked to leave eventually because he or she was very negative in the community for various reasons, and this happens all the time. But it's not like that information went anywhere, right? It didn't go to a code of conduct violation repository that then you can do text analysis on later. Maybe there should be something like that. That's the kind of data that you might be looking at for these kinds of things, and in that way you might be able to say, well, we cited the code of conduct, and then that was an incident. good luck trying to get a project to do that. So, yeah, it's impractical, but yeah.
For looking at equality systems, evaluating historically, can we go back to earlier groups like early Christians, early Protestants, etc.? Look at diversification of wealth, and evaluate how the early equality systems played out.
Yeah, so you can you can certainly go back to historical systems and try to apply some of these measures. I don't think there's any problem there. I think there are two main issues that you might run into if you're trying to engineer a current system based on historical data. And so one is that you don't necessarily know what your historical data is exactly, right? The error bars are huge. Like, you don't necessarily know the wealth of a particular population group in 50 AD or 50 CE, right? Like to anything more than 10%. So that's one issue. So if you're trying to engineer a system to 25 basis points, like 10% error is just like terrible. And then the second issue is that if you listen to historians and talk to historians or classicists, you should always be very wary of taking things from history, cultural context from history, and applying it to modern times. And so I think that is, or even cross-culturally today, it's very difficult to sort of apply the cultural norms of one society and compare against our society. I'm not saying that it wouldn't work. I'm just saying it'd be an interesting historical exercise. It wouldn't necessarily help us engineer today's systems. What we really need are today's data.
Well, in that case, wouldn't engineering a system today not necessarily apply to the future population and the future cultural norms?
That's right, it wouldn't. Yeah. So we're only kind of in a, you have to continually do this stuff, and it's a generational thing. You every 5, 10, 20 years, the culture is going to shift, and you have to shift with it. So.
Thank you so much. Thank you so much. I know there's a lot more questions, but we're going to keep going. And you'll be available for the rest of the day, right?
Yeah.
To answer questions.
Feel free to come and chat with me about this stuff. I'd be happy to talk to you.
Yeah, this is amazing. This is the kind of thing that human beings are supposed to be doing, measuring stuff and just debating about systems, right? So big round of applause. Thank you so much, Doctor.